Now we are going to look at the graphs of sec x, cosec x, and cot x. This first question, sketch the graph of y equals sec x in the interval negative 360 degrees to 360 degrees. If we start with our cos graph, so our cos graph starts at 1, and it makes this shape. So it starts at 1, it goes down to negative 1 at the bottom, and it's 0, and then it's going to cross at 90, it's at negative 1 at 180, it's at 0 again at 270, and back to 1 at 360, and going backwards, it's at 0 at negative 90, negative 1 at negative 180, 0 at negative 270, and back to 1 at negative 360. So that's y equals cos x. Now sec is 1 over cos. So whenever we're at 1, 1 over 1 is 1. 1 over negative 1 is negative 1. So it's going to be at all the points where it's 1 or negative 1. When it's at 0, 1 over 0, we can't do, we get an asymptote. So we're getting an asymptote wherever it goes through 0. And we're going to get this shape where as it gets closer and closer to 0, 1 over something really, really small gets really, really big. So we get this shape that looks like this. So that is our graph for y equals sec x. So we get asymptotes wherever it goes through 0. It's at 1 and negative 1 at the same time as the cos graph, and it gets closer and closer to the asymptotes but never touches it. Sketch the graph of y equals cosec x. So again, let's start with this time sine. So let's draw our sine graph. So that is our sine graph, and we're at 0, 90, 180, 270, 360. I'm going back negative 90, negative 180, negative 270, negative 360. So again, cosec is 1 over sine. So whenever we're at 1, 1 over 1 is 1. So it's going to be at the same place. 1 over negative 1 is negative 1. And whenever the sine graph goes through 0, 1 over 0, we can't do, we get an asymptote. So whenever the graph went through 0, we're getting the asymptotes. And then the same shape, so it gets closer and closer to the asymptotes, but never reaches it. So that is our graph of y equals cosec x. And cot. So again, cot is 1 over tan. So let's start with our tan graph. Our tan graph takes this shape. And the tan graph's got asymptotes. So the asymptotes are at 90, 270, negative 90 and negative 270. And it crossed 0 at 0, 180, 360. The tan graph repeats every 180 degrees. So that is our tan graph, y equals tan x. Our cot graph, so whenever it goes through 0, like the other ones, we're going to get asymptotes. So we're going to get asymptotes whenever our tan graph goes through 0. And then the cot graph kind of flips the other way around. So when we divide by something really, really small, we get a really, really big answer. And as we divide by something really, really big, we get a really, really small answer. So it kind of flips around. And so when we had an asymptote before, it's now going through 0. When you divide by something really, really massive, you get something really, really small. So it gets closer and closer to 0. It goes through 0. And then when our tan graph was negative, our cot graph's negative as well. Sketch the graph of 1 plus sec x in the interval 0 to 2 pi. Let's quickly sketch the cos graph. So the cos graph for 0 to 2 pi looks like this. So our sec graph had asymptotes and then took this shape. So we're moving everything up one space. So where we were at 1 here, it's going to move up to 2. At negative 1, which was here, it's going to move up to 0. So we're going to have our asymptotes at pi over 2 and 3 pi over 2. And we're going to be at 0 at pi. It's going to be here. And we're going to be at 2, 0, 2. Put that there. And pi 2, 2 pi 2. And then we've got the shape like so. Sketch the graph of y equals cosec x plus 60. So it's a shift of 60 degrees to the left in interval 0 to 360. So the sine graph looks like this. Then the cosec graph looks like this. And then we're shifting it 60 to the left. So our asymptotes are going to move 60 to the left as well. So the first one is going to move to negative 60. The one that was at 180 is going to move to 120. The one was at 360 is now going to be at 300. And our points, so that was at 91. It's now going to be at 31. And 270 negative 1 is now at to 10, -1. So we've got the same shape. So exact same graph, but shifted 60 to the left. And sketch the graph of y equals cot 2 theta in the interval 0 to 2 pi. So again, we had our tan graph, which was like this. And then I do our cot graph over the top. Which was shaped like this. Cot 2 theta, it's going to half all the x values. So it's going to squash it in. So instead of repeating every 180 degrees, it's going to repeat every 90 degrees. So the asymptotes, the one that was at 180 is now going to be at 90. The one that was at 360 will now be at 180. And it's going to repeat every 90 degrees. So we're going to have that whole shape. So where it went through 0, it was at 90. It's now going to be at 45. And it's now going to be repeating every 90 degrees.